Hello and good day to you wherever you are. This is Samuel Anekon. Welcome you to this channel. So in this video, we taking some exercises on the law of indices. This is our second lesson when it as regards indices. So before we proceed, I would like you to hit the subscribe button. If you've not yet subscribed to this channel, please do just go ahead and subscribe. Click on the like button as well and click on the bell icon so that you will always be notified whenever we upload any new video. So just grab your pen and paper as we proceed with this lesson. Thank you so much. Hello, good evening. In this lesson, we'll be looking at some exercises on indices. So we have four exercises that we're going to solve right now. The first one is simplify. Find the value of 4 raised to power minus 3 over 2. So the solution is going to be, this is 4 raised to power 3 over 2. Now, if this is your first class of indices, I would advise you go to our previous lesson, which was actually the introductory class on the indices, where I also taught the laws, all the laws of indices. Go to that introductory class. I'm going to put the link in the comment section, in the description section. I'm going to put a link there so that you can go to the lesson, that first lesson first, so that you understand the concept, the basic concept of indices before you proceed with this class. This is our second class on indices. So 4 raised to power minus 3 over 2. Which rule are we going to use? This is the reciprocal rule, the negative index rule. We're going to apply that here, which says that if a is raised to power minus n, then a raised to power minus n is same thing as 1 over a raised to power n. That is when a number or variable is raised to a negative power. This can be changed to over 1 over the positive power. So a raised to power minus n is same thing as 1 over a raised to power plus n. So with that here, 4 raised to power minus 3 over 2 can actually be written as 1 over 4 raised to power 3 all over 2. So right now, we are going to simplify the 4 raised to power 3 over 2. So taking 4 raised to power 3 over 2, what do we do with this now? So in the previous lesson, this is a fractional index. So we're going to split this. There are many ways this can actually be solved. There are many ways, a lot of ways. Okay, so I'm going to solve it in different, I'm using different method. Now, 4 is same thing as 2 times 2. That is the base 4 here. It's same thing as 2 times 2, which is the same thing as 2 raised to power. This is 1, 1, making 2 raised to power 1 plus 1, which is 2 raised to power 2. So 4 can actually be written as 2 raised to power 2. So having that in mind, 4 raised to power 3 over 2 is the same thing as, you replace the 4 with 2 raised to power 2. Okay, so now put that in brackets, then raised to power 3 over 2 in outside the bracket. Okay, so right now we have 4 being depicted by 2 raised to power 2 and the raised to power 3 over 2. We now put the 2 raised to power 2 in bracket and keep that outside the bracket. So now this power 2, this is power 3 over 2. We can actually multiply the powers together. So that will give us, at the end of the day, you have 2 raised to power 2 times 3 all over 2. 2 in the numerator cancels 2 in the denominator. You are left with 3 in the numerator. So eventually this is the same thing as 2 raised to power 3, which is actually the same thing as 2 times 2 times 2, which is 8. So the final answer over here is actually 8. Final answer for Sorry, this is not the final answer. 4 raised to power 3 over 2 is actually 8. So we can actually write this as one. We can actually write 1 over 4 3 over 2. We can actually write that as 1 all over 8. That can be written as 1 all over 8. Okay, 1 all over 8. Okay, 1 all over 8. Okay, so the value of this is 1 all over 8. Now I said we could actually solve this through different methods. So I'm going to use another method right now in solving this. So let me rub this off. From this point, when we have 4 raised to power 3 over 2, applying 3 over 2 is same thing as 1 all over 2 times 3. Okay, so I can actually write 4 raised to power 3 over 2 as 4 raised to power half times 3, which this can be written as 4 raised to power half. Put this in bracket, keep the 3 outside. Okay, so 4 raised to power half, keep the 3 outside right now. So 4 raised to power half is same thing as square root of 4. The 4 raised to power half, well, something raised to power half is an indirect way of finding the square root of that number. So root 4, then in bracket raised to power 3. Square root of 4 is actually equals to 2. Then raised to power 3. 2 raised to power 3 is equals to 8, just like before. So at the end of the day, 1 over 4 raised to power 3 over 2 is equals to 1 all over 8. 4 raised to power 3 is actually 8. That is a second method of solving. Okay, that is the second method of solving this question here. Okay, so even at this point, we could have just said, oh yes, this is one way this could have been solved further. There are a lot of different methods. There are a lot of different ways. You could have still replaced this with 2 raised to power 2. Okay, let's do that. So that is another way. So another way is that if you get to this point, instead of changing this to the square root of 4, you know that 4 is the same thing as 2 times 2. 4 is the same thing as 2 raised to power 2. So you replace 4 with 2 raised to power 2 here. Then you have raised to power half. That is multiplied by the half. Sorry. 4 is 2 raised to power 2 times 1 times half. Then power 3 outside. So what happens is that 2 in the numerator cancels 2 in the denominator. So this is 2 raised to power 1, 3 outside, which is same thing as 1 times 3 is 2 raised to power 3, which is equals to 8. So eventually, this 4 raised to power 3 over 2 is still 8 at the end of the day. No matter how you solve it, as far as you solve it correctly, you're going to end up that this is 8. The value of 4 raised to power 3 over 2 is 8. So at the end of the day, your final answer is going to be 1 over 8, no matter how you solve. So there are a lot of ways you can actually solve this. So now, we are going to move over to the next question, which is 64 raised to power 2 over 3. So we've finished solving the first one example. I actually use different methods to actually solve them, to actually show you that there are a lot of different ways that we can actually use to manipulate these indices. So now we'll be moving over to the next one. In case you have any question, you can actually drop it in the comment section, or you can connect with me via my social media platforms as well. And please, if you've not subscribed to this channel, please do well to subscribe and like the video, drop your comment as well. Thank you. So we continue right now. 64 raised to power 2 over 3. There are many ways, but I'm going to just use one way. Okay, I'm going to solve it in two different ways. So we could as well write it as 64. 2 over 3 can be written as 1 over 3 times 2. So you can now keep this in brackets and keep the 2 outside. So 64 raised to power 1 over 3. What do you do here? This is actually the same thing as the cube root of 3. The cube root of 3. Sorry, the cube root of 64, not the cube root of 3. That is the cube root of 64. That was a mistake. That is cube root of 64. 4 can break 64. 4 is 4 is 16. 4 and 16 is 4. 4 and 4 is 1. So 64 is equals to 4 times 4 times 4, which is 64 is equals to 4 raised to power 3. That is 1, 2, 3. Okay. 64 is same as 4 raised to power 3. Okay. So over here we have that in place of 64 you have 4 times 4 times 4. All brackets raised to power 2. The cube root of 64 is actually 4. Just pick one of the 4. 1, 2, 3. 1, 2, 3. Pick one. So 4 raised to power 2, which gives you 4 raised to power 2 means 4 times 4, which is actually 16. So final answer is 16. The 4 raised to power 2 over 3 is what? Gives you 16. The answer is what? 16. Answer is what? 16. Okay. This is actually 16. Okay. I said I was going to solve it in 2 different ways. So the second way, which I'm going to use right now, let me roll this off. It's going to be it's going to be 64 is even, so 2 can break it down. So you have 2 in 64, that is that 2. 2 in 34, 16. 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 into 1. So 64 is 2 times 2 times 2 times 2 times 2 times 2. That is 1, 2, 3, 4, 5, 6 twos. Okay, so 64 is the same thing as 2 raised to power 6. That is 1, 2, 3, 4, 5, 6 twos. Okay, so here you're going to replace the 4 with 2 raised to power 6 times 2 over 3. That is the power here, which was already there. You're going to multiply this power and this power together. So 6 times 2 over 3. 3 in 3 is 1. 3 in 6 is 2. 2 times 2 is what? 4. So eventually you have 2 raised to power 4. Okay? Which is actually 2 raised to power 4, which is which gives you this gives you 2 times 2 is 4. This is 16 at the end of the day. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So 3 raised to power 4 is 16. So the answer for this, the 4 raised to power 2 over 3 is 16. Just as the same answer we got previously. Okay. So we're going to move over to 0.001 in bracket raised to power 3. So I'm going to rub this off right now. So for C, we have 0.001 raised to power 3. How do we solve this? The best thing to do is to change this to the index form. This is the standard form. Sorry, the decimal form. So we're going to change this to standard form, index form. This is the same thing as 1, 2, 3. I'm moving the decimal point 1, 2, 3 outside. So this can be written as, how many times did I move it? 1, 2, 3. 3 times. This is written to 3 decimal place. So this is, when you're writing this in decimal, in the decimal, in the, this is in the index form, this is going to be 10 raised to power minus 3. So 0.001 is same as 10 raised to power minus 3. So 0.001 all raised to power 3 is same thing as 10 raised to power minus 3. Keep it in bracket, then bring this 3 outside. So at the end of the day, what do you have? Yeah, all you need to do is just to multiply the powers together. Minus 3 times 3. That gives you minus 9. So this, the value of this is 10 raised to power minus 9, which you can, if you want to put it in decimal form, you can actually write it as 0, 0, 0, 0, 0, 0, 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the decimal form. This is the index form. So that is the final answer for that question. So for the last one, which is 14 raised to power 0. So anything raised to power 0 from the last class, the rule states that any number raised to power 0, anything raised to power 0 is equals to 1. So for D, 14 raised to power 0 is equals to 1. The final answer there is actually 1. So with this, I've solved all the exercises on indices. This is just 4 questions. You can look for more questions and go ahead and solve them. If you have any challenge, you can connect with me through my social media platforms, either WhatsApp, Instagram, or wherever. So try and, if you've not subscribed to this channel, try and subscribe and connect with me via the social media platforms as well. Thank you so much. So in the next video, we'll go further in indices. Right now we'll go to solving exponential equations. So don't find a way to connect with that class and join that class and watch that video. Watch out for that class, watch out for that video. Our next video will be solving exponential equations. Thank you so much. So thank you so much for joining our lesson on this exercises on indices. Please, if you go over the video the first time and you still have problem, still go over it the second time again. And if maybe you try to solve some questions and you're having difficulty, you can contact us for our assistance. So you can connect with us via our social media platforms. On Instagram, my username is Edison for real. This is my WhatsApp number. And please, if you are yet to subscribe, please do subscribe and like the video. And if you have any challenge, you can drop it in the comment section or via our social media platforms. Also, we'll still have a further class on indices, a third class. This was second class. Our third class is going to be on we're going to look at how we can actually solve exponential equations. So don't miss out on that class. Ensure that you attend, and you can also invite your friends and loved ones. Thank you so much. Bye.